Okay, so today I am going to talk about how to use the graphing calculator a little bit more. So some people that don't have a graphing calculator may not want to watch this or do these problems. But those of you that either have a graphing calculator or plan to get one for the next year or two, this is very helpful. And in fact, some of my calculus students talk about how they wish they had a little bit of this prior to coming to calculus because that would make it a little bit easier. I'm just going to talk about a couple of things here. First of all, if you have a color calculator, when you graph the problems, they're going to show up in the different colors that you see here. If you don't have a color calculator, not a big deal. What you could do is you could change this right here and make one of the lines thicker or skinnier. But we're going to kind of ignore that for now. So I'm going to go ahead and plug in a quadratic equation. So let's just start with something small. The X is right next to this green alpha button. So I'm going to go X, and then the squared is the same spot it always is, plus 6. So what you have to know about these kind of problems is that the graphing calculator is always set up in the form of y equals. So if y is not all by itself, you're going to want to do some work for yourself to get in the form of y equals. So I'm going to go ahead and hit graph. And as you see, it looks like the x-axis are nice. You can see the tick marks. See how there's so many here in the y? It's because whatever I use the calculator for last, it remembers the xy axis. So I'm going to go up and I'm going to hit zoom. Standard window is always the one that you want to go back to. So I'm going to hit the number 6, which means the window goes from -10 to 10 on both the x and y. So you can clearly see that this is parabola opening up. But what the calculator can do for you is it can find the intercepts, which are your x answers if you were to solve, and it will also find the vertex for me. So we're going to take some time today, and I'm just going to talk about that. First, let's talk about the vertex. The last couple of days on our review assignments, we've been talking about how to find the vertex if the problem's in standard form or intercept form, or vertex form. Did I say that already? Anyways, the calculator will do it for you. So once your calculator or once your graph is there, you're going to hit second trace. Now, in doing that, it's using the calculations up here in blue. I can ask it for a lot of different things. So what you're going to be more concerned with today is the min and max and the zero. Because remember that the words zero and root and intercept and solution, those all mean the same. So let me go back to my graph now. This does not have any x-intercepts, therefore it does not have any real solutions because my graph is not touching the x-axis. But this here, I want you to look at it. This picture is called concave up. It looks like a smiley face. In that case, this one spot right here is the absolute lowest spot. The absolute lowest spot is called the minimum. So this vertex is actually going to be called the minimum. So when I go and click that second trace, I want to pick the minimum. So I can either arrow down until I get to number 3, or I can simply just hit 3. Then what happens is you see this blinking cursor. I'm going to use my arrow buttons. I'm going to go a little bit to the left of the minimum spot and hit enter. And then I'm going to go a little bit to the right and hit enter. Now what happens is you see those two arrows. So on the non-colored ones, you're not going to see the lines going up and down. You're just going to see the arrows. But they're saying you think that the vertex, the minimum spot, is somewhere in between those two. Well, we definitely do. We don't want to hit guess. We're just going to hit enter again. And it will tell us our exact answer. Now, let's take a look at this one. Down here where it says x equals. So you've got to realize that this is in scientific notation. That capital E like that is in scientific notation. It means times 10 to the -6, which you've learned in science classes. That means you move the decimal point 6 times to the left. So if I move this decimal point 6 times to the left, it'd be -0.000001, which is basically 0. So they're telling me that the vertex is at 0, 6, which makes sense. All right, let's look at a different equation. So I'm going to go ahead and hit clear, and I'm going to start all over again. 2x squared minus 8x minus 2. And I'm going to hit graph. Okay, so you can see it's, again, opening upward here. And it looks like it's hitting the x-axis in 2 spots. And it doesn't look like it's hitting right exactly at an integer, so which means it would be a decimal. So in the past, the only way you would have been able to do some of these problems might likely be either try to factor or the quadratic formula. But now you can hit those buttons, second, trace. We want to find an intercept. Well, another word for intercept is 0. So I'm going to hit 2. Now what's going to happen is I'm interested in the 0 here, but it says left bound. This spot is not to the left of that. So I need to arrow a little bit to the left, which actually means I need to be above the x-axis. And I'm going to hit enter. And then I need to go a little bit to the right side of it, which means I need to be underneath it. And then I'm not going to guess. I'm just going to hit enter. So my exact answer is negative 0.236068, 0. So if I were doing this and doing it as a quadratic equation, quadratic formula to solve it, I would probably have to round it out to about negative 0.2. And then we would do the same thing for the other one. So we'd hit second, trace, click 0 again. This time I need to arrow way over here. And this time, because it was going upward, I'm going to start, my left side is going to be a little bit under it, which it is now. And then my right side I need to go on the other side of the axis and hit enter. And here's my other 0. All right. Now let's talk about the vertex. You can see the vertex is somewhere down here. Maybe it's at 2. We're not really sure. So I'm going to go ahead and hit second, trace. And again, this is a minimum because my graph is opening upward, which means it's concave up. So there is a low spot. So I'm going to click 3. Now I'm going to I need to go on the left side of that bottom spot. So I'm just going to go a little bit more on the left side of where I think the bottom spot is. And then I'm going to arrow to the right side of it. And I'm not going to guess. I'm going to hit enter. And it's telling me that minimum is at 2, negative 10, which I could have found the minimum, which is the vertex, my own, without a graphing calculator, but this is somewhat a little helpful, especially when you take a standardized test. Okay, so let's talk about some other kind of problem. So what if my problem was this? So what I'm going to do is I can't put this in my graphing calculator the way it is. So what I'm going to do is I want to move the 10 over. So now I'm going to plug into my calculator this. And let's talk about one that maybe we already know what it looks like. So what if our problem was this in a regular situation? So I know how to solve it by hand, but let's say we wanted to graph it in our graphing calculator. You'd move the 25 over, and then you would type this into your calculator. So we always want to make sure that everything's on one side. 4x squared minus 25, and hit graph. So what's happening here is you can see the x-axis. Okay, so we're going to go ahead and click second, trace. We're going to pick 0. And so right now we don't see a cursor. And that's because if you look at where we're at 0, negative 25 right now. So what we need to do is move a couple of things we can do. We can move the cursor, and notice the numbers at the bottom keep moving until we can see it show up on our screen. Or what I like to do is, the answers between 2 and 3. So I'm just going to click 2, enter. Then I'm going to write 3 and enter. And that way I don't have to keep moving my cursor. And then do I want to guess? No. So they're telling me the answer is 2.5. Well, if you notice, this is symmetric, right? Because there's no middle term. So we know that one answer is going to be 2.5 and the other one's going to be negative 2.5. But you could go ahead and do it all over again. So now the problem is I want to find the vertex, but the vertex is so far down, I won't be able to see it right now. So I'm going to have to change my window. So I need to see more on the low end, and that means my y min needs to be changed. So I'm going to go down to the y min, and let's say I say negative 30, and hit graph. Now I can see that min, so I'm going to hit second, trace, min, a little bit to the left, hit enter, a little bit to the right, hit enter, and then I don't want to guess, I'm going to hit enter. So again, this is one of those questions. It's really 0, negative 25. All right, so let's try one that maybe is in intercept or vertex form. So let's say I go 2 parenthesis x minus 4 parenthesis x plus 2. And in fact, you know what? I'm going to go back and make that first number a negative 2. So instead of clearing everything away, and this calculator, I need you to see that there's a clear button, there's a delete button, okay? The clear button will clear the entire thing out. The delete would just delete one spot. Then on top of the delete, there's this INS, and it's in blue. So I'm going to hit second INS because I just want to insert a negative right there. I didn't want to retype anything, I just want to insert. Okay, now before I show you the graph, we should make connections here. So we do know it's negative 2 up front. Our A value is negative 2, which means the graph should be upside down, which means it's concave down, which means that instead of there being a minimum spot, there's going to be a high spot, and the high spot I call the maximum. But if you look at the parentheses, because it's already factored, those I can turn into zeros right away. So if I let x minus 4 equal 0, what should my answer for x be? 4. And the same thing for the other one, it should be negative 2. But let's just hit graph just to verify that. So is my graph hitting at 4 and negative 2? Yes. Now if I hit second trace, and I just want to verify, I'm going to go ahead and click 2 for a 0. Okay, I think it's in between 1, 2, 3. I think it's at 4. So let's say that we're going to go in between 3 and 5. I can just click 3 and then 5, enter. So I'm telling the calculator that I think the 0 is somewhere between 3 and 5, and I don't want to guess. I'm going to hit enter. See how they're telling me exactly it's at 4, 0. Now I want to find that vertex, and that vertex happens to be a high spot. So I'm going to go ahead and change the window now again. It's the high spot that needs to be changed, and that's a max for my y value. So let's say I change it to 20 and hit graph. Now you can see that maximum point. So I'm going to hit second, trace, max this time, so number 4. And I'm going to go ahead and hit enter because I'm on the left side of it. Go a little bit over to the other side. And they're telling me the maximum is at 118, which means my vertex is at 118. Now, I do know that you know how to find the vertex yourself, but again, the graphing calculator sometimes makes it a little bit easier. Now, we've been playing around with a window, so I would suggest that you hit zoom 6 to take it back to its standard window for the next time you use your graphing calculator. I think that might be it for today for the graphing calculator, but there is a lot more I could do with this graphing calculator.